All right. So chapter 2 test. Things that we should be able to do. Well, we'll have 2 questions where we're going to convert from degrees to radians. And I'm going to ask that you leave that answer as a fraction, like a fraction of pi. And we'll have 2 questions where we'll go from radians to degrees. And we're going to have 2 questions where I'm asking you to calculate some arc lengths. So you'll be using that arc length formula. I'll give you the formula on the test, so you don't have to memorize that. We'll have 1 question where I ask you to use our SOHCAHTOA definition for sine, cosine, and tangent to write the ratios. So like you'd get a right triangle and you'd say, okay, sine of angle A is, like 7/12 or whatever, right? I meant 2 questions where we ask you to do that. Okay. So then we'll have 2 questions that given 1 trig ratio so like I tell you that cosine is 5/9 and we'd ask you to find the other 5. One question where we give you a point on the terminal side of an angle. And then you'll want to find the 6 ratios. And then we'll have 1 question where we're given 1 trig ratio. And then the sine of another. And then you'll want to find one of the specific ratios. So it'll say in the question like, okay, find sine if cosine is 5/3 and tangent is negative or something. And then lastly, we'll have 2 questions where we ask you to evaluate the trig function using the unit circle. So I think that's like, what, like 14 total questions or something like that. So in terms of things that you should have memorized, you definitely need to know how to use like SOHCAHTOA. Probably already knew that starting the class, right? You'll need your standard position angle definitions of sine, cosine, tangent, etc. So things like sine is y over r, cosine is x over r, tangent y over x. You'd need to have those things memorized. Everybody okay there? Still basically the same thing as SOHCAHTOA though, right? You're basically just calling y is opposite, x is adjacent, and r is hypotenuse, and it's still the same thing. And then you'd want to have your unit circle definitions for sine, cosine, tangent, etc. memorized, which again is basically the same thing as the standard position angle definitions, except r is 1 in the unit circle definition. But you should have those things memorized. They would not be given to you. But the unit circle you'll get, the arc length formulas you'll get. You just need to know how to use those things. Questions about the test format stuff before we move forward? Jane? Yes. Yeah. And translating from the SOHCAHTOA definition to the standard position angle definition. Yes. And again, everything that I'm writing here is in the content library, so you don't need to copy it now. You can if you want, no big deal. But if you need to refer back to this and be like, what did he say again? You know, we're recording the lesson and this is all in the content library, so it's no big deal. Okay. Questions from the chapter 2 stuff. We had a bunch of time in class last time. And you guys probably worked a bit on the review and the homework problems and the worksheet and a whole bunch of stuff. Is there any questions on those things before we move forward? Landon? So from the review then? Okay. I think I'll have to drop that page in probably. So question 11 you said? Okay. Just grab that page. And you said B? Yeah. The letter B? Okay. Okay. So it says here, find secant if tangent theta is equal to 2 and sine theta is less than 0. This is definitely a kind of a question that I'd expect you to be able to do on the test. So this is a good one to ask about. So the first thing I'm going to do is I'm going to kind of start by drawing a picture. So I know that I'm going to be drawing a triangle in one of these 4 quadrants. The trick here is going to be figuring out which quadrant to do. So I know that tangent is y over x. Happy there? Yeah. Okay. So in this case, I know that the y has to be 2 and the x has to be 1. Or it could be y equals -2 and x equals -1. Could be that also, right? I'll write it up here. There wasn't enough space. Well, I can pick which one of those two I need simply because I know that sine is negative. I know that sine is y. So this is the one that I need. Everybody happy with that? So I know my standard position angle, the terminal side of it, is going to be in the third quadrant. And when I build my reference triangle, I know the x coordinate is going to be -1 and the y coordinate is -2. So far, so good. Remember, the side lengths on this triangle aren't really side lengths of a triangle. It's not like a physical triangle. They're representing the coordinates of that point on the terminal side. That's why the side lengths can be negative. Now we're looking to find secant, which I know is 1 over, well, no, this should be r over x is the definition I need to use because we're not on the unit circle. I've drawn just a point on the terminal side, so I need to use this definition. So the x we know is -1. We have to find r still, though. But that's not bad because I can just use the Pythagorean theorem to find that. So I know the hypotenuse squared is equal to the sum of the legs squared. So r is just going to be the square root of 5. Cool with that, Landon? Okay. So there's my square root of 5. So here we are square root of 5 over -1, or I can just call that negative square root of 5. Okay. So again, on all of these problems that we've been doing here, like on none of them the arithmetic is terribly complicated. What tends to give students issues is keeping the definition straight and knowing when to use which definition and how to determine when something's positive or negative. And it's like understanding the geometry kind of involved or the definitional, foundational stuff that's involved. But if you look at what we did here, we just used, like we used basic algebra stuff to kind of figure this thing out. It wasn't too bad from an arithmetic standpoint, but like required a lot of background knowledge, right? That we really had to apply these definitions in the correct way to reason out what was going on, which tends to be the hard part. So again, like practice doing the problems for sure, but you really need to make sure you understand like why we're doing stuff inside of the problems in this class more than even probably any of your previous classes, because something that can look very similar, you might do something kind of different because of the, like the definitions involved kind of, you know what I mean? Yeah. So we have to be a little bit careful here. But you're happy with what we did there? Yeah. Okay. Who's next? Jane. Question 10. Okay, I think I have that already, right? E, okay. So to do this, I'm going to be using the unit circle. The directions say use the unit circle to find the exact values. So I'm going to just drop that guy in here and shrink him down a little bit so I hopefully can look at the question and that at the same time. Okay. So the first thing I notice if I go by and I look at the radian values, 9/2 is not on my unit circle, right? So what I'm going to do is I'm going to find an angle that's coterminal to 9/2 pi, or 9 pi over 2, because it's going to have the same values for sine, cosine, tangent, etc. if the terminal side is in the same position, and our definitions are based off, a point on that terminal side, as long as the terminal sides are in the same spot, it's going to be the same values. So since 9 over pi, or 9 pi over 2 is in radians, I know I'm going to be adding or subtracting 2 pi. 9 pi over 2 is obviously too big, so I need to be subtracting. We're okay with that? Okay. So if I subtract 2 pi, I need to make a common denominator. Obviously, that common denominator is 2. So I'm going to have 9 pi over 2 minus 4 pi over 2. That gives me 5 pi over 2, which is still too big, right? 3 pi over 2 is the biggest fraction over 2 that I have, so I know I need to do that subtraction again. So I'm going to subtract by 4 pi over 2. That's the same as 2 pi after I make the common denominator. I just didn't feel like, I already did the common denominator once. I'm doing the same thing over again. Like, why write it another time? So that's pi over 2. So cotangent is x over y. So looking at pi over 2, I'm going to have x over y. So 0 over 1, which is 0. Does that feel okay, Jane? Alternatively, you could have done this by saying, okay, well, instead of going and finding the angle coterminal, or using arithmetic here, I'm just going to kind of do this visually. So like half pi, 1 pi, 1.5, 2, 2.5, 3, 3.5, 4, 4.5. So this is the spot that I need. You could do it that way and just kind of do it visually. That's okay. Do you see what I did there? I just basically counted around by half of a pi because 9 over 2 is 4.5. Or you could do this, you could do the arithmetic on your calculator. That would also be okay. So to do that, I'm going to ignore the pi's. So I'm just going to do 9 over 2 instead of 9 pi over 2. And instead of subtracting by 2 pi, I'm just going to subtract by 2. Let's do it. Oops. And what I'm going to do is I'm going to keep subtracting by 2 then until I get a number that's between 0 and 2. So I subtract by 2 once. That didn't do it. Do it again. That did it. And then I can press the math button and choose the fraction command to convert that back to a fraction. So there's my pi over 2, or 1 pi over 2 if you prefer it to write it that way. That's okay still. Does that feel okay? So again, finding that coterminal angle is the important part, is the kind of the tricky part about that particular question. We presented you a couple of ways to do it, whether it's by hand or graphically by hand or with a calculator. But that's essentially all you need to do in order to kind of get to the answer there. Who's next? Jane. B from question 7? Sure. Let's see. Question 8. Okay. Oops. So we're looking at this one, right? Okay, so it says you're standing in your own yard when you notice your friend is on your roof. Oh my goodness. Your friend measures an angle of depression to you of 26 degrees. If you know your roof is exactly 22 feet tall, How far away from your friend are you? Okay, so let's kind of draw a picture. So there's my yard. There's my roof with my friend on it. I know that the roof is 22 feet tall. And then it says an angle of depression of 26 degrees. So whenever you talk about like an angle of depression or an angle of elevation, you're always talking about relative to that person's line of sight. So it says your friend, so it's talking about the person on the roof. So if they're looking straight ahead, that's like their line of sight, right? So an angle of depression of 26 degrees means that like they looked down 26 degrees. Is that okay? And the distance we're looking for then is that distance between the straight line between you and your friend. Does that feel okay? Okay, so I'm going to just translate this now into a triangle. And I know that this side here and this side here have to be the same, right? Because vertical things are parallel. So now I'm just going to use SOHCAHTOA to solve for the missing side length. So relative to the 26 degree angle, this side is opposite, and this side is the hypotenuse. So I'm going to use sine. Pen, why did we stop working? Oh, there we go. So we'll say sine 26 is equal to 22 over x, opposite over hypotenuse. To solve for x, I'm going to multiply both sides by x. And remember, sine 26 is just going to be like some crappy looking decimal. So x times the decimal. To move that decimal over, I just need to divide by it. So 22 divided by sine 26 is what I'm going to type into my calculator. Before I do that, though, or before I calculate, before I type this into my calculator, I do need to check the mode my calculator's in. Since I'm about to use sine, cosine, or tangent, I need to make sure that my calculator's in the proper mode. So I'm going to press that mode button right next to the blue. Since I'm doing sine, cosine, or tangent of an angle in degrees, I have to make sure my calculator's in degree mode, which mine is already. If yours isn't, you just use your left and right arrows to kind of move to where the degree is. Your cursor's on the degree, and then just press enter, and it'll switch it. But we're all set here. So I'm just going to do 22 divided by sine 26. So I get about 50.2 feet. Does that feel okay, Jane? Follow-ups on this one, or are these new questions? Okay, Landon?
On the review, you got a different answer.
Let's look then. What did we do? Okay. Okay. I see. Okay, so it appears I just solved for the wrong thing. I solved for like how far away are you from your house? because I solve for this side, which is the distance from me to my house. The distance from me to my friend is this side, so I just solved for the wrong side. But we really had the same picture. So that's my bad. Gabby. Of course. Victoria, did you have a question on something? Oh, okay. Perfect. Thank you guys for pointing that out to me, though. We'll make an update on that. Jane, do you have another one?
No.
Oh, okay. Landon?
So if we go to question 4, like the next section, is there going to be one of these problems on the test?
No, I don't think I read something like this, right?
I just don't remember if you said this was.
Yeah. No, but this is definitely like an ACT style question that if you're a junior and you have that coming up, this is definitely the kind of thing that would, potentially make it onto your ACT is this kind of a question. Because it's hard to fake knowing what the answer is without actually being able to do it.
Yeah.
Okay. Anybody else? Takers? Movers and shakers? Alrighty then. I need you guys to clear your desks other than something to write with and your calculator. Probably not, but if you decide you need one,
I don't care, man. I don't care.
There's 2 questions. One of them has
Yeah.
a couple of parts of it, but it's mostly just using the units.
Start on the
Sure, I don't really think you need one for this, but
Never mind.
it's okay. I have a couple. So it's not looking for the point, it's looking for the value of cosine of 210.
So, like,
Remember on the unit circle, cosine is equal to,
a degree.
so you're using your unit circle definition for like sine, cosine, tangent.
Yeah, so you, like for that, you go here.
Right.